Hello, welcome to Crank Software's Embedded UI Live series. I think we're good. Hi, I'm Fletcher, Vice President of Crank Software, and I'm looking at a live camera in a new configuration. We made some adjustments for our UI live stream, and so today I'm going to be talking to you about MPUs and MCUs in the context of embedded UI development. And so hopefully this new configuration works out. We can see everything. And we're responding to some feedback that we've received. Thanks, Dad. It was great to get it. Hopefully everybody can read the board today. We will be using a similar poster style. And we'll be working through a few scenarios today where we talk about the role of MPUs and the role of MCUs in embedded UI development and how that's changed. So this is the start of a series where we're going to be exploring how embedded UIs work in these two different configurations. But we thought we'd start the series with just enough information to kind of establish a baseline. What is an MPU? What is an MCU? How do they differ? So we're going to start with that today and talk about that and put it in the context of embedded UI development. So MPUs. MPUs are our typical microprocessor configurations. These are the desktop type systems that we've often used scaled down to work in embedded environments. When we talk about MPUs, what we're talking about are systems that are fairly sophisticated but also general purpose. They aren't fully integrated. They are chips that require peripherals, that require support from other systems. Just to kind of put it into context, right, what we're talking about are systems like an IMX6, like an Intel x86 system. If you're looking at evaluation boards, things like the Raspberry Pi, the BeagleBone, and the BeagleBoard family of prototyping boards. Those type of systems where you have a very capable processor, a lot of peripheral support integrated into it. And one of the things that's particularly interesting about MPU systems is really a lot of them will also contain an MMU for memory management. And this is an important consideration when we think about embedded UI development and what it takes to actually drive a UI. Now, Crank Software has been doing embedded UI development for over 10 years. When we first started, a lot of our products were in this space, right? Automotive products, IVIs, dashboards, those type of configurations were sitting in this space. Medical devices is another area. Anybody that wanted a rich, sophisticated UI was typically using an MPU configuration. On the other side of the coin, we've also seen different types of processor configurations. MCUs. What's an MCU as compared to an MPU? The difference here is the C. It's a controller. It's a microcontroller. So it tends to be a much simpler system, a system that tends to be much more integrated, where an MPU relied on a lot of peripheral support, memory controllers, I/O controllers, potentially even external graphics configurations and boards. An MCU tends to be fully integrated. It brings all that functionality together in a simpler configuration for you to build into your product, but it also tends to be much more single-purpose, right? It doesn't run a variety of different applications all simultaneously. It tends to run just one thing. So if we're thinking about the types of boards and configurations, especially in the context of embedded UI development in today's world, we're looking at boards and platforms and configurations from ST Micros, things like the STM32, F4, F7, H7 class processors, from NXP, the RT series, the 1060s, the 1050s, and Microchip. Microchip has a lot of different controllers. The PIC32 family in particular is something where they're playing a role in the embedded UI families. So these type of configurations, much simpler, much more single purpose. What type of applications are using these? Well, they're used for control system type configurations. Things where you're doing I/O, data collection, a little bit of management. Think HVAC systems, thermostats, oven controllers. Those type of systems tend to fall into the MCU category. Historically, MCUs have not had a lot of embedded UI interaction. And that's simply because they were much simpler systems. Because they were fully integrated, they frequently didn't have a lot of memory capacity, a lot of resource capacity. You were really looking at building code, deploying it down to a target, and then integrating it fully as a whole system. However, if we think about the type of applications that we're running, when we think about HVAC, when we think about air conditioning, when we think about control systems, there's been a shift. And so here are two, kind of types of products that we might be seeing in the market today that could be using an MCU controller. And what's different about these systems? Well, you'll notice that they are very focused on I/O control, right? A coffee maker needs to monitor the I/O, do measurements, do data collection and reading, but ultimately it's a very single-purpose type of device. Similarly, this air filtration system, very sophisticated, but also single-purpose, right? Not a general-purpose type of application. What's interesting here is this aspect of these products, right? These are embedded products that have integrated a LCD display into their configuration. And if they're running in an MCU configuration, what does that mean? Well, as soon as you start putting a display on, one of your big requirements is the requirement for memory. And so if we were to take this tiny little display here, it might be a little difficult to see through the web interaction here, but let's assume that it's 128 by 128 pixels, a relatively small display. That display, if it was using a full 32-bit color, full red, green, blue alpha channels, would use roughly 64K of RAM, right? That needs to be available to the system. And if you were a simple system and you don't have integrated memory, that's a big chunk to pull out of your chip's core. So this is why it's typically be in the realm of MPUs. However, what's interesting is that the recent MCU families have started integrating more memory capabilities. And what that's really done is that's opened up the door and brought them a little bit closer to the typical MPU configurations. Now you're seeing MCUs where they're shipping with 128K of RAM, 512K, a meg, 2 megs, even 10 megs in some cases, where that's really opening up the ability of these MCUs to start running richer graphic displays. And you can see here in this configuration, the size of your graphic display, as it grows, the memory requirements grow quite significantly pretty fast, right? A 480 by 272, which is a common display size, still relatively small in terms of pixel density, is going to occupy half a meg of RAM for one single display buffer. Typically, you're going to want to double these, so you're looking at a meg of memory just for the purposes of the display. Now, we're going to talk about this in future sessions. Here I'm talking about 32-bit color displays. It's easy for us to decimate that down, chop it in half, bring it down to 16-bit colors, or there's other techniques that you can use to reduce that memory footprint. But what is essential is that the MCU needs to have memory on board, and part of the evolution of the recent MCU systems is that they have integrated that memory. Now, it's not just about your memory configuration. One of the things about an MPU is that they typically are much more powerful processors, right? Running at gigahertz or higher speeds, where MCUs are still powerful in their own right, but you're talking about 100 megahertz, 200, 400, 600 megahertz in terms of speed. So once you start putting graphics operations where you need to be shuffling data back and forth into memory, now what you're looking at is a challenge of how can you fulfill the original objective of what the MCU was supposed to do and at the same time render rich graphics, right? Render a display, render a UI. This is also being solved not just by the integration of more memory, but by the integration of rendering libraries, rendering technologies in order to accelerate those graphical operations. And here, some cases we're talking about full GPUs. For example, in the NXP case, we have the PXP graphics accelerator. In the ST Micro situation, we frequently will see a DMA2D engine. And that integration is key to allowing an MCU platform to support the graphics, right? To support that rich interaction and still fulfill its operational role inside the product in terms of the control systems or the I/O that it needs to do. Still single purpose, still very much sort of a focused product device, but a simpler configuration overall, and with the integration of more memory and advanced graphics rendering capabilities, making the MCU really come over and start digging into some of the spaces where we would have typically seen an MPU processor being used. That's the hardware story, right? That's the configuration story around hardware differences between MPUs and MCUs, right? Where we're talking about level of peripheral support required for configuration, and we're talking about a simpler integration story. But there's more to the embedded UI aspect of development. There's also the consideration of what's your operating environment looking like. So on the MCU side, we're typically seeing a much more real-time executive style operating system, while on the MPU side, we see a much richer operating environment in terms of its model. And a lot of that has to do with this notion of what kind of memory access is being provided and what is the system looking like in terms of its configuration. QNX, Linux, Android, these are all systems that typically will rely on a process model with processes executing independent from one another in a memory in a memory separated space, so that the system can be a little bit resilient in terms of component failure. One component failing or writing into a block of memory doesn't actually affect the other components. This is an important consideration for product resilience, right? Being able to support your product in a variety of different flexible considerations, which is why it tends to be tied to the general purpose configurations of an MPU. However, the other piece that's really interesting is the development style. When you're working with a QNX system, when you're working with a Linux system, you tend to leave the system live and running all the time. You configure the system image, you're running individual processes, and one of those processes is probably your user interface, right? Your graphics component. So in a piece where you're likely to be changing it, you're likely to be iterating through changes on a very frequent basis, being able to do that rapidly, being able to iterate over that very quickly with simply a software reset effectively is really important here. And this is a big boon on the MPU side in terms of your development speed, your ability to iterate very quickly over change in the context of a UI, right? And we all know that UIs change on a very regular basis, right? They are very, very fluid. There's a lot of change and feedback cycles that go into developing UI. And it's one of the things that Crank really focuses on with our Storybook product. If I compare that working model to what you see with an MCU, where typically you're using a real-time executive type of configuration. What's the difference between a real-time executive and sort of our standard operating systems? A real-time executive offers many of the operating system functionalities in terms of task management and synchronization, timers, but it offers it in a way where that isolation that you get with the process model that's coming partially because of the MMU factor, right, the memory protection, that's not there. It's also a different mindset. Typically when you're working with these systems, you're not looking at soft resets. What you're doing is you're assembling the entire system to work together in one system image, one system load. And there are techniques that you can use to segment this up and to break it up so that your development cycle doesn't have to always involve rebuilding and reflashing an entire system image. But because of the integrated nature of the MCU configurations, that is typically what you are doing. Now, there's always exceptions to the rules. You can run Linux on some of these configurations, and it really depends on the richness of the resources that are available to you in terms of the memory and the flash storage. How much resources do you have available to partition and give to the operating system as overhead as compared to the rest of your application and execution? So this is a slower development model, right? Now, again, in the context of embedded UI development, where a lot of change is happening, as a slower development model, having to rebuild the system, flash it down, see it, not quite right, have to go make changes. This tends to be a slower model, so you end up using a lot more simulation techniques. You end up using a lot more scaffolding where I'm building an application, but I'm building it in a framework that I can execute in my desktop environment, or maybe even in an MPU environment as a simulation for the product without having to actually always deal with the hardware. This can speed up development time, but ultimately when you actually want to see the display running and you actually want to interact with it, it's important to be able to not just have a simulation environment, but be able to run on the real hardware. And this is where Storyboard excels, because regardless of whether you're using an MPU or an MCU, our technology allows you to use a common development model to bridge back and forth between different deployment models, whether you're deploying to QNX or Linux or Android, or whether you're deploying to a FreeRTOS, a MuCOS, a ThreadX type of system, agnostic of the hardware, agnostic of the rendering technology. You can pick the platform that gives you your development support so that you can quickly iterate change on the embedded UI and then put it into context rapidly. So today we've talked a little bit about the difference in configurations between MPUs and MCUs, and we've talked a little bit about how MCUs have been growing their feature set, remaining an integrated platform, but growing their feature set in particular in areas that embedded user interfaces are really interested in. Memory, graphics capabilities, right? To allow us to run rich user interfaces in these configurations. MPUs are not going away. They're here certainly for a long, long time. Lots of specialized applications require the type of power that those processors have. But when you get into singular applications, an MCU can be a great choice of development, especially in some of these new integrated platforms where you've got all of the capabilities you need to put forward a rich user interface. There are a breed of processors that don't necessarily fit into the MPU category or into the MCU category, right? MPUs, typically thinking of them as Cortex A9 class systems, and MCUs, typically thinking about them as Cortex or the ARM class type systems. But if we're using integration as the differentiation, there's a lot of crossover components that sort of sit in this middle space, and a lot of interesting opportunities for embedded user interfaces. Hopefully you found this session interesting and engaging, and you learn a little bit about MPUs and MCUs and how they have been changing over time to further support embedded user interface development. I'm going to take a look right now and see if there are any questions. Let's see what we've got going on here. Is this going to be a recorded webinar? Absolutely. These live streamings are sitting on our YouTube site. They are available for download after the fact. And I have a question here, which is a technical question, asking how easy is it to move from one type to the other when building UI? Say if your project needs change. Absolutely. It really is going to depend a little bit on the technology that you use. Different technologies offer different support. Some technologies bind themselves in very, very tightly to the graphics capabilities that are being offered, whether it's on the MCU side, the MPU side, or on the MCU side. A technology like Storyboard tends to be a little bit more agnostic so that you can develop at arm's length from both the processor, the graphics, and the operating system. So if you have a product, for example, that is an MCU-based product, perhaps it's a low-cost variant of your product, less feature-rich, but still you want to have that UI presentation, that rich presentation, you might use FreeRTOS, and you might use an RT 1050 or 1060 to provide that low-cost platform. But maybe on a higher-end system where there's more functionality, more integration with other componentry, you might be using a Linux system or QNX system as an operating system base to give you more technology access. And you might be using something like an IMX6 or an IMX8. The same design can flow back and forth if you choose the right technology. Will there be any functionality lost if I scale up or down? Absolutely. We're not talking about parity of MCUs to MPUs in all areas. Certainly, if you look at a graphic design that tends to be flat, relatively, rich in color, right, rich in graphical assets, that will move across, relatively easy. If you're looking at functionality that may be leveraging 3D GPU capabilities that are available on the MPU systems, those functionalities are unlikely to move across to the MC. So what you're really looking at is a system where you can design a degradation, right, that matches your MPU and MPU and MCU capabilities in a reasonable fashion, right? And Storyboard is one of those systems where you can degrade gracefully. One of the other questions that I've seen is, what about SOMs? So SOMs, or system on modules or system on chips, are really an attempt for the MPU configuration, right, to take more of its functionality and package it up into a bit more of an integrated solution. So when I talk about crossover type solutions, while a SOM is not an MPU or an MCU, it is a packaging story, right? And companies like Toradex provide readily available modules that package up an MPU, put it together with different flavors of technology in terms of I/O controller and whatnot, so that you can get some of the simpler integrated componentry into your product design. Looks like there's no more questions. Again, I'm Thomas Fletcher. Thank you very much for attending our Embedded UI live session today. Hopefully you learned a little bit about graphics, MPUs, MCUs, and the integration that happens for embedded UIs in those spaces. I look forward to seeing you in another couple weeks for our next session. And until then, be safe, get a haircut.